in range. So I needed to jump on another slide here as I ran out of room there. But domain, range. Okay, if you go back and look at your graph, if you think about it, the domain and range are going to be the same thing. X includes all real numbers, and y is greater than or equal to 0, and y includes all real numbers is the range. Because we're never going to cross the x-axis. We'll always be above, so y will always be greater than or equal to 0. Okay, and our graphs will always carry on left and right. So there is no really restrictions on the domain. Okay. When it comes to our piecewise function in part D, okay, remember it's y. That's quite the y there. Okay, y equals, and we put our bracket in there. Remember, it's positive x squared minus x minus 2, and it could be negative x squared minus x minus 2. Okay, so now we have to determine what values of x do we plug into here and get a positive answer, and that way we can just pull it out. And what values of x do we plug into here and get a negative answer, so that we have to multiply it by a negative to make it positive. Okay. Well, if you remember, back to the first example, the numbers that we used were our x-intercepts. That doesn't change here. Okay. What we do is we plug in, and that got messy there in a hurry. -1 and 2. And we just have to decide now, where is the function negative? Is the function negative in between here, or is it on the outsides? All you have to do is plug in a test point. Okay? If you plug in a test point, okay, plug in, okay, so a test point to be 0. So, sorry, let's sub in 0. So if we sub in 0, we'd get 0, we get 0, so our answer would be -2. So when we sub in numbers in between the two x-intercepts, when we sub in numbers in between, it's going to end up being negative. So if the absolute value is negative, that's when we have to multiply by a negative. So that means that our piecewise function, okay, we have to express it as negative if, okay, x is less than 2 and greater than -1. And the function is positive, and we can just pull it out if x is greater than or equal to 2 or less than or equal to -1. Okay. That there is our piecewise function. Okay. This is the interval on which this will be positive, so we can just pull it out like this. This is the interval on which this will be negative, so we have to times it by the negative. Okay, this stuff, the process to get to here, we've done already. Okay, when we did quadratics, when we did solving quadratic inequalities. Okay, so that is nothing new. How to get to here, okay, how to write this is new, and that can be a little tricky. But if you can just remember this, of how to figure out where this would be positive and where this would be negative, by using a test point, or if you want to use sign analysis, whatever, then it's actually pretty straightforward. It's really not that difficult. Alright, just a quick review of what we did here in this video. You can analyze absolute values functions in several ways. Graphically, by sketching and identifying the characteristics of the graph. okay, including the x, y intercepts, the minimum values, domain, and range, you can algebraically rewrite it as a piecewise function. Okay, remember, as a piecewise function, it looks like this. Okay, we pull the function out positive where the function is greater than 0. We pull it out negative where the function is less than 0. The domain of an absolute value function is the same as the domain of this. Okay. The range of an absolute value function, okay, depends on the range of this function. For the absolute value to be a linear quadratic function, the range will generally, but always, be this. Okay, so like we saw in our examples, the two examples that we did, and more often than not, it's just going to be y is greater than 0 when y includes all real numbers. Again, here's your assignment. We'll work on this tomorrow, the next couple of days. Okay, so come to class tomorrow ready to get to work.